All right, greetings, my students. This is the first lesson for Module 9B, Lesson 1, Transformation Definitions. So yes, this portion of Module 9 is strictly on transformations. We're going to first discuss the definitions and then apply them towards the end of this video. All right, so keep in mind, you are most welcome to pause, hit the pause button, hit rewind. Make sure you understand and get down everything you need to get down into your notes packet. All right, so here we go. Lesson 1, transformation definitions. Transformations basically move a function on a graph. So if you take a look at the graph here, this is what we will call the parent graph, the original graph, the original function. And as you can see, you can clearly identify in the yellow highlighted region the coordinates of this parent graph. So what we're going to do is we're going to identify those coordinates. Starting with here in quadrant 3, we have a -5, -4. I'm going to put that in the table to the left. This is our parent table. Then we have -2, +1. Next we have 4, 2. And finally, our fourth point is 5, 5. So our notation that we will be using for transformations will be f of x. This is our parent graph. The parent function is the original function. We don't have an equation for this particular one, but it will be in function notation. And then, of course, our parent table with the parent coordinate points. So these are your original XY coordinate points. So for purpose of this lesson, we will be using this parent graph with this parent table that have these parent coordinate point values. Okay, so for the first transformation, we're going to talk about the horizontal shift to the right. Now, our notation for that is f of x minus h. So the original notation for our parent function is f of x. That is the original parent function notation. Here, because we're having a shift to the right, we're doing a minus h. Minus h. This is a horizontal shift to the right. So take, for example, we were to have f of x minus 3. What we would do is we would do the opposite by adding 3 to our x values. So notice that we are subtracting h from x. We're going to do the opposite by adding 3 to x. So we're going to add 3 to all of our x values. -5 plus 3 is a -2. -2 plus 3 is a +1. 4 plus 3 is 7. And 5 plus 3 is 8. Okay, so what kind of shift is this called? This is called a horizontal, and you can abbreviate horizontal, shift to the right by 3. A horizontal shift to the right by 3. So whenever you're asked to describe your transformation, this is what you would say: a horizontal shift to the right by 3. And take note, it's in the opposite direction. So this means that this becomes my new x coordinate, and I'm going to stick to my original y coordinate. There's no transformation along the y-axis. So when I go to plot these points, I have the following. I have -2, -4. And notice how that is a shift to the right, 3 spaces, 1, 2, 3. And then I have a 1, 1, which is right here. And again, that's a shift to the right, 3 spaces. Next, I have a 7, 2. Again, shift to the right 3 spaces, and then an 8, 5. And that too is a shift to the right 3 spaces. So now when I go to connect these points, this is what my transformation graph looks like. You're going to use a straight edge. Always use a straight edge. If you are not using a straight edge, trust me, I will take points off. You can use the edge of your ID card, you can use a ruler, anything that will give you a straight line. So voila, we have graphed a horizontal shift to the right. And the specific example we used was x minus 3, f of x minus 3. Okay, let's go ahead and examine a horizontal shift in the other direction, to the left. So here we have f of x plus h. Notice the sign difference. This is now a plus h. And the specific example we're using is f of x plus 2. So what we're going to do here, folks, is we're going to take the opposite of plus 2 and we're going to subtract 2 from our x values. Now keep in mind, this is happening to x. It's happening to x, and we're always going to do the opposite of whatever happens to x. I repeat, we will always do the opposite of whatever is happening to x. So we're going to subtract 2 from our x values, our parent x values. This becomes a negative 7. Negative 2 minus 2 is a negative 4. Negative 2 plus 4 gives us a positive 2, and negative 2 plus 3 gives us that positive 3. So before we plot our new x and our original y coordinates, I want to use words to describe our transformation. So we're going to describe our transformation calling this a horizontal, and again you can abbreviate, horizontal shift to the left by 2. Horizontal shift to the left by 2. You need to know how to use words to describe your transformation. Horizontal shift to the left by 2. So let's go ahead and graph this. Remember, we're going to the left by 2, so if I'm going to the left by 2, these should be my new coordinates. And let's check it out. We've got a negative 7 comma negative 4. Yep, that seems to be the case. We've got a negative 4 comma 1. Yep, that's what we have here. A 2 comma 2. That's what we have here. And a 3 comma 5. That's exactly what we have here. Now, once again, you're going to use a straight edge and graph these points using a straight line in order that you plotted them. So it should resemble your original parent function. Okay? It's just a horizontal shift to the left by 2. Okay? Turn the page. Now we're going to talk about vertical shifts. Here's the notation for a vertical shift. We're going to look at our f of x function, our original parent function, and the vertical shift going up is going to be a plus k on the outside of the parentheses. A plus k on the outside of the parentheses. So this is not happening to our x. We're not doing a horizontal shift. We're doing a vertical shift, and a vertical shift goes hand in hand with the y-axis. Vertical means up and down. So we're going to use a specific example. Let's call it f of x plus 4. This is going to go up by 4 because it is up. 4, positive 4. We obey the sign. We will always obey the sign. So over here, we go up, we obey the sign, and we are going to write in words that we have a you can abbreviate, vertical shift up by 4. you need to know how to write this in words. Vertical shift going up by 4. Okay, so just for writing that, that's like 3 points right there. Okay, so let's go ahead and address the table. Since this is happening on the outside of our parentheses, it is happening to our y-axis, our y variable. So I'm going to add 4 to my y variables. Here we go. 4 minus 4 is 0. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 5 is 9. And so now we have our new xy, well, our original x and our new y coordinates. Okay. So we're going to go ahead and plot those points. Negative 5, 0. Negative 2, 5. 4, 6. And 5, 9. So notice how everything went up by 4. Everything went up by 4. So I'm taking my original parent function, parent equation, parent function actually. Whoops. Let's undo that. Taking the whole thing and shifting it up by 4. Here we go. So it still resembles the original parent function. It's just shifted up by 4. Okay, moving on. Vertical shift going down. Vertical shift going down. So take, for example, we have our parent function f of x. We are going to subtract our k value. K represents our shift going up or down along the y-axis. Going up, it is plus k. Going down, it is minus k. So a specific example here, let's go ahead and graph f of x minus 5. There's a shift that's going to go down by 5. So let's go ahead and write that out in words. We have a vertical shift. Again, you can abbreviate. Vertical shift down by 5. Miss K, do I have to write all that out? Yes. Yes, my darlings, you do. Vertical shift going down by 5. So let's make it happen. Some of you don't even need to use a table, but I want you to use the table. Some of you can just count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Yeah, okay, you can count. You can do it that way. That's fine, but I need you to show work. When you show work, you're showing understanding. So here we go. We're going to subtract 5 from our y values. Remember, we obey the sign here. Okay, we're obeying the sign, and I meant to switch up the colors here, darling. So sorry about that. I'm going to obey the sign here. I wanted to match this, so I apologize. Subtracting 5 here. This gives me a negative 9, negative 4, negative 3, and a 0. So once again, let's see if we plotted these points correctly. Negative 5, negative 9. Indeed, we did. Negative 2, negative 4. There it is. 4, negative 3. There it is. And 5, 0. There it is. So we know we totally did this correctly. You are going to make sure you use a straight edge to graph your points. And voila, there you have it. Vertical shift up versus a vertical shift going down. All right, folks. Again, because I am a bit anal retentive, I'm going to rewrite that. Here we go. This is a vertical shift down by 5. Okay, color coordinated. Now I'm happy. All right, coming back here. Now we're looking at reflection over the x-axis. Reflection over the x-axis. Here's what the notation looks like. You have a negative a. So your reflection is here. Your a is a 1 in this case. Negative a times your f of x, your parent notation function. So for example, we have a -1 times f of x, which is the same thing as saying negative f of x. So do we have to write the 1 there? Absolutely not. You can just simply put a negative sign in front of your parent notation f of x and call it a day. So when we go to describe in words what this is, you're going to write reflex over x-axis. Okay, so what does that mean for our table? Well, for our table, that means we're going to multiply, because notice how we are multiplying here. We are multiplying here. So that means we're going to multiply to our y values. It's happening on the outside of x. It's not on the inside of x. It's on the outside of x. So whatever happens on the outside of the parentheses, it's happening to y. So we're going to multiply a -1 to our y values. So once again, this becomes +4, -1, -2, and a -5. These become your new y values. This is your x sticking to the original, and this becomes your new y values. So when you go to plot these points, this is what your reflection over the x-axis looks like. Remember, we are reflecting it over the x-axis, so it's going to fold over your x-axis. Here's what it looks like. -5, -4 is up here. -2, -1 is down here. Notice how it's across the x-axis. Then we've got a 4, -2 below the x-axis, and a 5, -5 below the x-axis. So go in order that we plotted the points and draw your lines using a straight edge. And there you have it. You graphed the reflection over the x-axis. Now let's talk about reflection over the y-axis. Note the notation, how it varies, how it's different from reflection over x-axis. So your notation here is going to be f of -a times x. Notice how it's on the inside. This is happening to x. So whatever's happening to x, we're going to make sure that we make it happen to x on our table. So an example here would be f of -1 times x, which is equal to f of -x. So I'm showing you that we do not need to write -1. We can just put a negative sign in front of our x and call it a day. So how do we write this in words? Remember, this is a reflection over the y-axis. So you can write this as reflex over y-axis. Yes, you have to write out the whole thing. Reflex over y-axis. This is math literacy. So you need to know how to write it in words. Okay, so once again, note the difference between reflection over x-axis and reflection over y-axis. Over here, it's happening to x, so we're going to go ahead and multiply a -1 to our x values, because notice that we are multiplying a -1 to x. So here we go. This becomes a +5, +2, -4, and a -5. So these become our new x values, and we're going to pair it with our old y values. Here we go. 5, -4. Notice again, it's going to reflect over the y-axis. So I'm just drawing that there to show you that there's a reflection across that y-axis. If we fold over the y-axis, we're going to get our points on the opposite side. Okay, now we have 2, 1 right here, negative 4, 2, and then negative 5, 5. And once again, you're going to draw your lines using a straight edge. Connect all your points, and you can clearly see the reflection over the y-axis. Okay, turn the page. We're going to talk about stretches and shrinks. 2 types of stretches, 2 types of shrinks. We've got a vertical stretch and a horizontal stretch, and we've got a vertical shrink and a horizontal shrink. Let's talk about vertical stretches and vertical shrinks first. Let's examine the notation. Once again, we are doing something to our parent function, our parent notation. When we have a vertical stretch, this is when we are multiplying a number in front of our function, outside of the function. So we're going to call it a. The notation is a times your f of x parent function, where a is greater than 1. A has to be bigger than 1 for it to be a stretch. So our example here is 2 times f of x. In words, we call this, and it has to be verbatim, you can abbreviate, vertical stretch by a factor of 2. Yes, you have to write that whole thing out. Vertical stretch by a factor of 2. Okay. So what does that look like for our table? Now remember what I said. Anything that happens outside of these parentheses, outside of x, is happening to our y's. So since this is multiplication, we are going to multiply by 2. We're going to multiply our y values by 2. Multiply by 2. Make sure you write mult up there. We're multiplying by 2. Here we go. This is 2 times a negative 4, which is negative 8. Oops, I wanted to use the other color. Multiplying by 2 because this is multiplication. Here we go, negative 8, positive 2, positive 4, and positive 10. So keep in mind, we're just multiplying to our y values to get these values. Now that we have our new y values, we can go ahead and pair them with our new y values, our old x values, okay? Here we go. Negative 5, negative 8. That's down here. We're stretching this guy out. Negative 2, 2. Uh, 4, 4. And then 5, 10. Right up there. So when we go to graph this, this is what it looks like. And you can see the stretch is just doubled. The stretch is just doubled. This is a vertical stretch. Let's go ahead and examine vertical shrink. So it's going to get squished here. So if we have a vertical shrink, our notation is going to look like a times your parent function f of x. But this time your a is not going to be greater than 1. Your a is going to be greater than 0, but less than 1. Greater than 0, but less than 1. So yeah, it's going to be a number. Think of a number line between 0 and 1. And it's going to be a fraction between these guys. Okay? For those of you who needed the visual. So let's take, for example, we have 1/2 our a is 1/2, times our f of x function. So what that means is we have a vertical shrink by a factor of 1/2. Yes, you have to write that whole thing out. Your table, here we go. You are multiplying by 1/2. Remember, this is multiplication. You're multiplying by 1/2. So half of -4 gives me a -2. This is 1/2. This is 1. And then this is 5/2. Or, darlings, you can write 2.5. That works. It helps with your graphing. When we go to plot our points, -5, -2. There we go. -2, 1/2. Notice how everything is shrinking. We've got 4, 1, and 5, 2.5. I can do better. There we go. So now go ahead and draw your lines using a straight edge. And there you have it. Vertical stretch versus a vertical shrink. Now let's go ahead and talk about horizontal stretch and horizontal shrink. So over here we talked about alterations made on the outside of the function of x, f of x. That happens to our y values. Over here, when it's a horizontal transformation, we are looking at what's happening to x. So this is going to be called f of b times x, where b, for a stretch, it's going to be less than 1 but greater than 0. Now remember, we always do the opposite of whatever is happening to x. So take, for example, f of 1/2 x, right? 1/2 times x. Yes, I'm multiplying, but I'm going to multiply by the reciprocal of 1/2. I'm going to multiply by the reciprocal of 1/2, which happens to be 2. So I multiply by 2. Okay, this is what's going to give us that stretch. So we do the opposite. Reciprocal, I'm going to put opposite. It's not necessarily, you know what, I'm not going to even write opposite. It's just reciprocal, because opposite would imply the opposite sign, and I don't want to do that. I'm multiplying by the reciprocal. Here we go. I'm going to write it in words. This is going to be a horizontal stretch. I'm not going to even write that whole thing out. Let's abbreviate. I'm going to abbreviate. Horizontal stretch by a factor of 2. Okay? Horizontal stretch by a factor of 2. So you're stating the reciprocal, not by 1/2, but 2. All right. Over here, multiplying these guys by 2 gives us a -10, -4, +8, and +10. We're going to go ahead and plot these points, -10, -4. Right down here, -4, 1, 8, 2, and 10, 5. And there we go. And there is your horizontal stretch. It stretches all the way to the left and to the right in a horizontal direction. Let's go ahead and take a look at horizontal shrink. So suppose we are looking at, again, f of b times x, only this time your b value, yep, you guessed it, your b value is greater than 1. So for example, I have f of 2 times x, right, 2x. I'm going to do the opposite, the reciprocal. Once again, I'm going to multiply. It's going to happen to my x because this is a multiplication that's happening to my x values. I'm going to multiply by the reciprocal. I'm going to zoom in and write reciprocal. Okay. And the reciprocal of 2 is 1/2. So I'm multiplying these guys by 1/2, negative 5/2, or negative 2.5. This is a negative 1, positive 2, not a negative. Half of 4 is 2, and half of 5 is positive 5/2, or positive 2.5. So before I graph that, let's get the wording out before I plot those points. This is going to be a horizontal, abbreviate, shrink by a factor of 1/2. Horizontal shrink by a factor of 1/2. You are stating the reciprocal. All right, let's go ahead and plot these points. We have negative 2.5 comma negative 4, which is right about here. Negative 1 comma 1, right about there. 2 comma 2. And 2.5 comma 5. So once again, use a straight edge, draw your lines. And notice how you have a horizontal shrink. It's squished in. It's squished in together. It's pinched in from the sides. All right, folks, let's go ahead and make sure you memorize this. This is what you must understand and know for your transformations. I'm going to choose a different color here. Let's choose blue. All right, so your A value represents your stretch, your vertical stretch or shrink. Your B represents your horizontal stretch or shrink. Your H represents your horizontal shift. And K represents your vertical shift. You need to know this. All right. I'm going to go ahead and do numbers 1, 2, and 3 with you, and then we'll discuss the rest in at another time, probably in another video. All right, multiple transformations. We're going to use PEMDAS to describe our transformations. This is the order we are using. We always talk about multiplication and division before addition and subtraction. So our first description is always going to talk about reflection, stretches, or shrinks. So take, for example, in number 1, we've got a stretch out here. So we're going to state the first transformation, which is a vertical stretch by a factor of 2. The second is a horizontal shift. Remember, we do the opposite direction of the sign. Horizontal shift to the right, not the left, to the right by 3. Okay, let's do it again in number 2. In number 2, we clearly see we have a negative out front. So we're going to address that first because that is multiplication. This is a reflex over x-axis. And if you're not sure, folks, you can always go back and check in your notes. For the x-axis, the sign is on the outside. The negative sign is on the outside. For y-axis, it would be on the inside. Okay, next, we have a 2 times x. This is going to represent a horizontal shrink. Remember, we do the opposite of whatever is happening to x. Whatever happens on the outside, we obey the signs. Whatever's happening on the inside of our parentheses to x, whatever's happening to x, we do the opposite. So this is a horizontal shrink by a factor of the reciprocal 1/2. The reciprocal of 2 is 1/2. And then last but not least, folks, we have a vertical shift. It is a shift, and it is positive, so it goes up by 3. Okay? So this is listing transformations in order. We're listing all the transformations in order. Take a look at number 3. Okay, we're going to start on the outside, work our way in. On the outside, we have a vertical shrink. We've got this vertical shrink. By a factor of 1/2. It is a shrink. Remember, a is less than 1, but greater than 0. So it is a vertical shrink. Remember, vertical, everything on the outside. Horizontal, everything on the inside. So on the inside, we have that negative sign. This means that there is a reflection over the y-axis. Reflects over y-axis. And then last but not least, we have a -4, so this represents a vertical shift down by 4. Vertical shift down by 4. Okay? All right, folks, this concludes your notes. Your 4, 5, 6, and 7 is going to be practice.